Alright, Bismillahirrahmanirrahim. Assalamualaikum. Alright, you tak dengar suara I ke? Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So we continue our syllabus on chapter number 2. This is organizing data, right? So in chapter number 1, we already learned what is the definition of statistics, and we already know the definition of population, sample, and we have learned some of such sampling techniques such as random sampling techniques and non-random sampling techniques, right? And now, after data are being collected in this topic, right, data are next ready to be presented and organized in understandable forms such as table, charts, or graph. So in this topic, we're going to learn how to construct table, how to construct or develop a chart or graph, right? So as we know in last topic, we have learned that variable can be divided into two types. First is qualitative variable. Another one is quantitative variable, right? So we're going to look at how to organize qualitative variable and quantitative variable as well, right? So first, let's start with a qualitative variable. So qualitative variable can be organized in some forms such as frequency table, relative frequency table, 2x2 table, or two-way table. 2x2 table or two-way table we known as a contingency table. And the chart that we can draw from a qualitative variable data is a simple bar chart, component bar chart, percentage component bar chart, and multiple bar chart and pie chart. This is a common uh, graphical method to cater qualitative data, right? So when you develop or construct a chart or graph, you need to pay attention on the graph title, axis title, legend if you have, right? Source of the data, right? And then of course the chart must be measured dia punya axis, right? Axis should be measured correctly, right? Now we look at the first part. So frequency table. Frequency table is a table showing the number of observation in each category or class. So this is example of a frequency table. So this is an example of frequency table. First, we have the category or categorical variable. The second column, we have a frequency value. Frequency value. So each row represent class, right? Each row represent class. So for this example, we are looking on qualitative variable. For example, this is an example for marital status. We have unmarried, married, and divorced. So on the second column, we should indicate the how many person unmarried, how many person married, and how many person divorced. And the last row, it should indicate the total number of observation, right? So this is common frequency table, right? So in frequency table, we should include relative frequency. Relative frequency, this is a subject which is our x. This is a frequency, small letter f. This is a relative frequency. In the topic number 6, we will learn more detail. We call it as probability of x or relative frequency. So as we know, 86 out of 280 are unmarried person, right? So to calculate relative frequency, 86 divided by 280, you will get to 0.307. And you need to make sure in relative frequency, the total value of relative frequency should always equal to 1. right? It should always equal to 1. So this is example of a frequency table and frequency table with a relative frequency for qualitative data, right? So you can refer this note in your book. So now let's look at the second part, which is a simple bar chart. So the simplest graphical presentation of a qualitative data is a simple bar chart, right? Simple bar chart can be present in vertical chart or horizontal chart, right? So, simple bar chart is useful when comparing item of a variable in more than 2 categories, right? If you have more than 2 categories, is the best chart to use is simple bar chart, right? So now look at example number 6. So at this point, you should have your own graph paper, right? So we're going to learn how to draw a simple bar chart. So this is example of simple bar chart, right? So you have bar to represent each category, and each bar to one bar to another bar, you have a gap between first bar and the second bar to the third bar to the fourth bar. You have a gap. So this is a bar chart. And then on the y-axis, this is y-axis, and then this is x-axis, right? On the y-axis, always present frequency value, and x-axis representing a categorical value, right? The height of the bar representing frequency value, right? So this is, let's see, look at example number 6. Diploma in accountancy, we have 180 students. So we need to draw bar to 180, right? Of course, the value for y-axis, you should measure correctly in a graph paper, right? So if you wrongly put the scale of the measurement scale on y-axis, so when you want to do some interpretation, you will get a wrong interpretation, right? So now let's look at how to, let me put this way. So let's say you have a graph paper, right? So let's say this one, you have graph paper. So this is your graph paper, for example, again. So when you want to start with drawing a bar graph, right? So remember, y-axis always represent a frequency. In this case, this is the number
Hah?
of,
Iya, wih, paham. Iya.
right? So let's say you need to have a good measurement scale. So let's say we look at this value at the frequency value. We try to find the highest number. The highest number is 220. So it means that you need to fully utilize your graph paper. Make sure you draw until 220 or 214. Right? The maximum value should be 214 or higher than that. Higher tak boleh lebih sangat, sikit-sikit saja. Let's say I'm using 20 scale, 20, 40, 60. Right? Next, on x-axis, we will present your categorical value. Right? You will present your categorical value. So based on table number 6, you have 4 category. So you should allocate 4 category equally. For example, let's say the first axis ni, you need to have some space lah, right? For the first bar. Let's say I take kotak number 4 ni lah. I give 4 box for the first category, and the second category should always have equal width. Maksudnya this one you have 4 box, this one also 4 box. The next one 4 box again. The next one 4 box again. Right? So need to adjust this one. Right? So this is your program. So this is going to be represent diploma in accountancy. This is diploma in computer science, and this is diploma in business study, and this is diploma in public admin, right? So for diploma in accountancy, you see the frequency value is 180. So you tarik 180 lah. So draw it properly. 180. So this is going to be your first bar for the first category. For the second category is 164. 164 maybe somewhere here, right? And the next category is 214. 214 somewhere here. Right? And the last one is 152. 152 maybe somewhere here. Right? So now, once you are already draw the bar for each category, right? So don't forget to write down your title of the graph. This is a bar chart showing number of students by program, right? So the title of bar chart should consist, the title of each chart should consist the name of the chart and the variable involved in the chart. So the variable is number of student and program, right? So if you have time, you can color inside each bar, right? So this is how you draw a bar chart, right? So this is what we call as a vertical bar chart. So if you have, you want to draw a horizontal bar chart, so just flip this bar to 90 degrees. So let's say, so dia akan jadi macam ni lah, for example. So this is horizontal bar chart. But actually, horizontal bar chart dia macam ni. The title of the graph should be up here lah, right? Okay. Now we move to the next type of chart, which is a component bar chart or stack bar chart. So component bar chart, some book will call as a component bar chart, some book will state as stack bar chart. So it's the same meaning. So component bar chart, unlike simple bar chart we only have a single value for each category. For component bar chart or stack bar chart, we're going to have more than two or more value for each category. For example, you have two, for example number 7, you have two value variable, which is program and gender, right? In gender, let's say the second the second category variable, this one, you can have more than two category. Let's say category 1, category 2, category 3, and 4, right? For this example, you have two category. So in program diploma accountancy, you have male and female. And of course, this is a not complete table. You need to extend another column to indicate total of the value of each category, right? So this one should be 110 plus 70 is 180. And this one should be uh, 160, 164, and this is 214, and the last one is 152, right? So you need to have total for each category. This is the main category, which is our program. Program is our main category. So this is a sub or what you call group category, right? Group category. You have male and female, category 1, 2, and 3, right? So let's look at component bar chart. Component bar chart is actually same as simple bar chart. Let me copy this chart again. Right. So let me copy this one. I want to change the title. This is not going to be a simple bar chart anymore. So component bar chart is based on simple bar chart, which is for a diploma in accountancy, you have the total of 180. So we have a total of 180. For diploma accountants, diploma computer science, all the total are indicated in as in the simple bar chart. So for each category, so you will divide the category to gender. So for diploma accountancy, we will divide male and female. So male is 70. The number of male is 70 out of 180. So you need to highlight this one. So the lower part is indicating male respondent. This is 74, should be somewhere here. This is 100, somewhere here. And the last one is 64. 64, somewhere here. Right. So let's say we use color to differentiate. Don't worry about the link, right? Later we'll give the new one, right? So for component bar chart, you need to use color pencil to indicate the difference between each category. Let's say I use pink color for male respondent, right? Third bar. And I'm using blue color for female. Now, the next step is we need to draw a legend to differentiate between the color, the category. So let's say we use, we draw the box out there, blue color and Another one is pink color. This one going to indicate this is female, this is male. So this is what we call as legend, right? Now the title should be a component bar chart showing um, number of student by program according to gender, right? So again, I repeat myself, the component that you need to include in the title of the graph, you should have the type of graph and the variable involved in the graph, right? So this is what we call as a component bar chart or stack bar chart, right? So the best way, if you want to add some more, you can add the value of frequency value for each. This one going to be, this is 110, this is 70, this is 90, this is 74, 114, 100, and this is 88, and this is 64. So you may take a while to copy and try to do or develop a component bar chart. Right. So this is what we call as a component bar chart. Now let's look at another chart, which is a multiple bar chart or cluster bar chart. Now we try to do a multiple bar chart. So multiple bar chart, same as cluster bar chart and simple bar chart, it based on simple bar chart. So multiple bar chart, instead of having stack, right? For this one, for component bar chart, we are stacking uh, the bar together, and we will get the same value, the same height, or the total height of each bar is the same as simple bar chart. But for multiple bar chart, it's quite different, right? We need to clear this one. So for each program, so for the first category, we have diploma in accountancy, right? So in diploma accountancy, we have separated the category to male and female. So let's do for male. For male, we have 70 respondent, right? So we put here, let's say I take four box, where I take two box out of four box. So this is going to be, this is category for male, and category for female is 110. So I take 110. Right? So as usual, we color pink color for male and the blue color is for female. So we done for the first category. For the first category, diploma in accountancy. Right. So this is how we do a multiple bar chart, and we continue uh, for the next category, which is diploma computer science. Male is 74. Somewhere here. This is, yeah. And oops. You should draw for yourself as well. And this one going to be 90. And this one should be 100. The next one is 114. The next one is 64. And the last one is 88. Right? So you should have taken initiative to draw right now, right? As in multiple bar chart, you should also have legend, right? You should have box of legend to indicate the color of each category. So this is female and this is male. So female is blue color, male is pink color, right? And don't forget the title. a multiple or cluster bar chart showing a number of students according to gender. Right. So we already look at simple bar chart. In simple bar chart, we already know horizontal bar chart and vertical bar chart. And then we already look at component bar chart, or what we call as a stack bar chart. And the last bar chart we already look at is a cluster bar chart or multiple bar chart. So as per now, we already know 4 type of charts in bar chart, right? Are you okay? So far, do you have any question? Do you have any questions so far?
Tak dengar.
Any question?
Buat suara.
So far, do you understand how to construct bar chart? So far we already know we have 4 type of bar chart: simple bar chart with the vertical or horizontal bar chart, and then we already know cluster bar chart or multiple bar chart, and we also know component bar chart or stack bar chart, right? Right. So since you understand good, then we can proceed with the next uh, chart in under qualitative variable, which is a pie chart. So pie chart, right? Let's look at pie chart. Let me copy this one. Oops, I tak boleh copy. Let me use snipping tool to copy this one. Right. Okay, good. You understand? So this is the last chart for qualitative variable. So for for pie chart, right, we're going to have a circle chart, right? You need to circle carefully, right? And then in the circle we are going to have a locus point, right? Right. And then we're going to start with the first 12 o'clock point. Let me use this one, right? For example, oops. We're going to start at here. So now, before we calculate the value of the angle, first we need to find the percentage of each category, right? So pie chart is suitable when you have a single value of a single variable of qualitative variable, right? So now the percentage of diploma accountancy is 180 divided by 700, 180 divided by 710 is equal to how much? 180 divided by 710 is 25.35%. Right? You know how to calculate percentage, right? 180 divided by 710 multiply with 100%, you got 25.35%, right? And then 164 divided by 710 is 23.09, right? Later we will round to one decimal place. And then 214 divided by 710 is 30.14%. And the last one is 152 divided by 710 is 221.40, right? So let us calculate the total value. It should have 100%. If you don't get 100%, then something you need to round off. So let's say I round off this one to 35.4, and this is 23.1, and this is 30.1, and the last one is 21.4. Can we get 100% here? Right. So we got 100% here. Right. So next we need to draw another column to calculate the angle. So in circle we have 360 angle, right? 60 degree, 360 degree. So how to calculate 360 degree for each the angle for each category? 25% multiply with 360. 25%, wait, 0.254 multiply with 360 is going to be a 91.44, and 23 this is 83.16, and this one 30.1, this is 108.36, and the last one is this is 77.04, and the total should be equal to 360. So you need to make sure the total is 260. And next step is we need to measure using projector. 91.4 degree should be somewhere here, right? And the next one is 80 degree, somewhere here. The third one is 108, somewhere here. Yep. So you need to use pencil color. You color this first one is a diploma in accountancy, right? Diploma in accountancy, or if you don't want to use color also can, right? This is a diploma in accountancy, 25.4%. Diploma in computer science, 23.10%. And this is diploma in business study, 30.10%. And the last one is diploma in public admin, 21.4%, right? So this is example of pie chart. If you want to use color, then you can include legend, right? Include legend to indicate the color code. And don't forget, you should have title, right? The title should consist the name of the chart and the variable or the variable involved in the chart. So a pie chart showing number of student. Sorry, we use percentage, right? Percentage of student by program, right? So remember again, in title should have the name of the title, the chart and the variable involved. So this is the important element in writing title of the graph, right? So far, do you have any question? For the next subtopic, which is organizing quantitative data, right? For qualitative data, right? In quantitative data, we can also organize in some forms such as a frequency table, relative frequency table, or contingency table. And the chart that involved for quantitative data is a stem and leaf display, histogram, frequency polygon, frequency curve, and cumulative frequency table, and frequency cumulative curve, which is OGIF, right? Now, this is an example of frequency table and relative frequency table for quantitative data. As same as qualitative data, we have a category, and then we have a frequency, and this is a relative frequency, right? So real frequency notation as small letter f, and relative frequency we note as probability of x, and this is the x value, right? So this is example for discrete quantitative data. We have number of children 0, 1, 2, 3, 4, 5, 6. And remember, the last row should indicate the total of each category. The total of the total frequency for each category, right? So each row represent class, right? This is class number 1. This is class 2, 3, 4, and the 6 lah, right? And this is the frequency value. The number of family who does not have any children is 22 out of 200, right? And then we have relative frequency. So the formula of relative frequency are same, which is frequency divided by summation of frequency. Means the frequency of each that class divided by the total number of frequency, which is 200, you will get 0.11. And the total of relative frequency always equal to 1, right? So this is one example using discrete quantitative data, right? And the second part of frequency table is also a frequency table for quantitative data, but this is based on interval range from 10 to 19, 20 to 29, right? This is based on range interval. And the last example of frequency table is based on less than value, 600 less than 800, 800 less than 1000. The following column still remain frequency and relative frequency. This is not X, but the difference between the first table and the second table is, for the first table, we already have the X value because it represents a whole number. But for the second table and third table, we don't have X value. This is not your X value. This is your class column. This is your class column, right? So to get the X value, which is your midpoint, right, middle value, right, we need to calculate with using some formula, right? So now I just want you to get familiarized with the category frequency table for quantitative data, right? So now we're going to learn how to construct a frequency table and relative frequency table for quantitative data, right? So now, when constructing frequency table or qualitative table for quantitative data, we need to consider some factor. First is number of class, class size, class limit, class boundary, and the last one is class mark and frequency. We have 6 elements that we need to consider for quantitative data, right? Are you clear with that one, right? So now, I'm going to explain to you the first part. Number of class. Let's look at frequency table number 3, right? Number of class is how many row you have. This is the first class, second class, third class, and so forth. So here we have 1, 2, 3, 4, 5, 6, 7. So we have 7 class. And the number of class cannot be too small or too large for quantitative data. If it's too small, some important features may be hidden, right? And if it's too large, we often to get a frequency equal to 0. So that's why if you have a quantitative data like this, example number 9, this is an example of quantitative, this is a quantitative data. We have unstructured quantitative data. It's not a group data, right? So here we're going to plan how to calculate. We want to construct frequency table. So let's say I draw a box to indicate frequency table, right? And this box we have 3 columns basically, right? Column number 1, oops. Column number 1, column number 2, and the last column is indicating this is your class, this is your frequency, and this is a relative frequency. So this part you need to listen carefully. If you don't understand this part, then you cannot construct a frequency table for quantitative data, right? So now we want to determine number of class. So for the first part, number of class, we will use the formula K is equal to 1 plus 3.3 multiplied with log 10n, log n 10. So where n is the number of observation. If you have your calculator, take out your calculator. Where is mine? Right. So now, based on example number 9, so this is example regarding the owner of mini market has recorded number of customer purchasing at his market for 40 consecutive days, right? So basically we have capital N equal to 40, right? So we need to find k value. K is equal to 1 plus 3.3 log n 10, log 10, right? So k is equal to 1 plus 3.3 multiply with log 40 base 10. Right? So this one should be equal to how much? So log 40 multiply with 3.3 plus 1. So you will get 6.28, right? So when you have 6.28, right? So let's say we take 6 as our k equal to 6, right? So when you have 6, you need to draw 7 class. So you need to understand, kalau kita ada satu buah tembikai, kita potong satu kali, so we're going to get 1, 2, 2 class, dua bahagian. So K is number of cut. So from 40 data, we want to cut to 6 part. We're going to cut 6 times. So we're going to get 7 class, right? This is class number 1, class number 2, class number 3, so 1, 2, 3, 4, 5, 6, 7. And the last going to be total. So the last, this one should be total, right? So now we already settled for the first part. Now look at the second part. The second step. Second step is we need to determine the class size. The class size is the weight of a class and it can be obtained using the formula class size equal to the largest data value minus smallest data value divided by number of class. It means that range divided by k. K is equal to 6. Right? So the largest data value, class size means, kalau kita tengok dekat sini, for example, table number 2. Class size mean what is the size for class number 1. So from 10 to 19, so what is the class size? How many number involved in this class? We have 10, 11, 12, 13, 14, 16, 15, 16, 17, 18, 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You cannot simply minus 19 minus 10. You will get 9, which is, this is wrong. You omit value of 10. So you need to count from 10, 11 until 19. So class size here should be equal to 10, right? So now to determine class size for our frequency table, we need to determine what is the highest value. So the highest value is 215. So we need to find class size. So 215 minus the lowest data value is 100, I think 121, is it? 121. Is it correct? $218 is the highest value kan? Mana 218? somewhere here, yes, right? So 218 is the highest value. The lowest value is 121. Divide by k. Our k is equal to 6. So divide by 6. So what is the value here? 218 minus 121 divided by 6. So you will get 16.17. So we will use 16 as our class size. So now the lowest data value is to 121 until we need to add another 15 value. So 121 plus 15 should be equal to 136, right? So this one 121 plus 15 equal to 136. Remember, our class size is equal to 16. So if you want to include 121 inside, you need to add another 15 value. Right? So this one is 137 plus 15 is equal to 152. 153 equal to 168. Right, this is 169 until 184. 185 until 200. 201 to 216. 217 to 232. Right. Next step is we need to count how many observation lies into class number 1. So class number 1 is 121 to 136. So 121 to 136. So is that it? So we have 1, 2, 3, 4, 5, 6, 7. We have 7 observations. So you put 7 here. Right? For the second class, we have 137 to 152. 137, somewhere, this one, include, and then this one also include. Sudah kan? Right, we have 4, is it? You correct me if I'm wrong, right? You need to calculate, count carefully because this is going to be very tricky, right? 4. And for the third class, only 3, is it? So 130, this one, the first one, yes. The second one, yes. This is not included. This is not included. Where is another one? Can you calculate for me? Can you count for me? I give permission to Nuri Shakira to annotate my draw to my slide. I give you permission. Wait. Nuranisa Shakira. So can you write for me? Letak berapa? Tulis kat atas slide ni. This one the third class ni dapat berapa? You boleh tulis. 10. You guna ni. Sekejap. Tulis balik. The fourth class ada berapa? Or you just tell me. You stop controlling my ni balik. You bagi I permission balik. I dah tersilap bagi kat you semua. Wait ah. For the third, for the fourth one, you dapat berapa? 190, 169 to 186, 84. Berapa you dapat? One hundred ninety, 69, 284. This one 69, 84 here. 11 for third class, is it? So kalau 11 kita letak 11 lah. Alright. So this is going to be 11. For the fourth class, you dapat berapa? How much for the fourth class? Fourth class you got 6, is it? 6. The next 185 to 200, how much? 185 to 200, this one include, this one include, this one not include, 200 include, and next, berapa? 3, is it? This one include, yes, so 5, right? So it should be equal to 5. Is it? You kira betul-betul? Maybe I'm wrong. I tak nampak dah. The second last, 201. 6 also. Okay, 6. Right. So this one should be 6. And fourth class, you got 7. Can you count carefully? This one, 180. So this one, 84 tak termasuk. 200 included. This one, 185 included. And then 188 included. Right. This one also include. So 1, 2, 3, 4, 5, 6 lah. Correct lah. Is it? Ada 8. 7. Mana you dapat satu lagi? The first, second, third. Ni tak termasuk. 184 tak termasuk. 180 tak termasuk. Satu tujuh lapan. For class. For class is what? Can you speak up? For class dapat berapa?
Class 7, sir.
1, 2,
Class
3.
got 7.
For class got 7. The fifth class kan dapat berapa?
Yang apa tu?
This one dapat berapa? 6. Is it? I got 6.
2 3 5.
This one 200.
Gila aku buat shoot. Oh,
So 1, 2, 3, 4. I thought 4 here. And the last one is 1. Right?
siapa Azek?
Can you mute your microphone? Right. The total should be equal to 40. Kalau tak sama, then something wrong somewhere. Yep. It's equal to 40. Right? So relative frequency is a very simple process. 7 divided by 40. It should be equal to 0.175. 4 divided by 40. 0.1. And 11 divided by 40 is 0.275. And 7 divided by 40 equal to 0.175. 6 divided by 40 is equal to 0.15. 4 divided by 40, 0.1. And the last one, 1 divided by 40 is equal to 0.025. And the total should be equal to 1. Right? The total should be equal to 1. Right? So this is how you construct a frequency table for quantitative data. Right? Okay. So now let's look at example number 10. Quick look. So example number 10, we have time taken in minute for 25 patients to see doctor in the clinic on a particular day is given by the following frequency table. So this is a frequency table for a quantitative data, right? So we have 2 to 2.99, 3.0 to 3.99, until 6.00 to 6.99. Now, tadi apa yang kita buat, kita baru tengok sehingga class size, right? Number 2, class limit kita tak tengok lagi, class boundary kita tak tengok lagi. Now, I'm going to explain what is a class limit. Class limit should be set up so that there should be no overlapping of class, right? So the class limit of a class are highest and lowest value of a class. So every class has two class limit, the lower class limit and upper class limit. Now, in class limit, let's look at this value. If you see this is lower class limit for the first class. This is upper class limit for the first class, right? This is lower class limit for the third class. This is upper class limit for the third class. This is lower class limit for the last class. This is upper class limit for the last class, right? And class limit, if you notice, upper class limit of the first class is not equal to lower class limit of the second class, right? Upper class limit of the class is not equal to the lower class limit of the next class. You see, 32 is a upper class limit for the third class. It's not equal to the lower class limit for the fourth class. So this is what we call as a class limit, right? Class boundary, if you look at this one, upper class limit for the first class is equal to lower class limit for the second class. Upper class limit of this class is equal to the lower class limit of the next class. So this is what we call as a class boundary, right? So this row, this class, we have a class boundary. This row, this table, for this table, we don't have class boundary. We only have class limit. Can you differentiate between class limit and class boundary? Right? Again, this is very important. By looking at this table, right? This table, we don't have class boundary. We only have class limit because upper class limit for the first class is not equal to the lower class limit of the next class, right? For this table, we have a class boundary because upper class limit of this class is equal to lower class limit for the next class, right? So now, if you want to calculate a class boundary, you want to create a class boundary, or let's say look at this table, table number 1 here. If you want to calculate class boundary, so 22 plus 23 divide by 2. Upper class limit of the class plus lower class limit of the next class divide by 2. So it become 22.5, right? So lower class limit sini 22.5 juga. So this one going to be 27.5, 27.5 until 32.5, 32.5. This is 37.5, 37.5 to 42.5, and so on. So by looking at the trend, kita nampak sini this one going to be 17.5. Right? This is how we calculate class boundary for the frequency table which don't have a class boundary, right? Hope you understand that one. So next, what we need to look at is a class mark. Class mark, right? If you recall for this table, if you can recall from this table, we can see that for this table, the first table, kan, each class has only one number, one single number, which is 0, 1, 2, 3, 4, 5, 6. They don't have any value, interval value or less than value, right? So then, because this is came from a discrete quantitative value, right? So since they don't have a class interval, right? For each class, ini is a class interval. So this is your x. This is your x. This is your class mark, right? For the second table and the third table, we have a class interval. We have interval class, right? So from 10 to 19, from 70 to 79, for 600 to 800, right? So to calculate the class mark, let's look at this one, right? To calculate the class mark is the midpoint of a class. So every class has a class mark. So class mark, upper class limit plus lower class limit divide by 2. Or if you have a class boundary, you just plus upper class boundary plus lower class boundary divide by 2. Same as class limit juga. So now, by looking at, kita tengok table ni, this table, right? This table, right? So if you want to find class mark, right, which is class, right, class mark. For this table, we don't have a class boundary. We have 18 to 22. So 18 lower class boundary, which is 18 plus upper class boundary 22 divide by 2. So you will get 20. So this is your class mark. 23 plus 77 divided by 2, which is equal to 25. 28 plus 32 divided by 2 equal to 30. 35, 40, 45, and the last 50. Right? Right. So this is how you calculate a class mark for frequency table which don't have a class boundary. So for this one, for this table, we have a class boundary 17.5 to 22.5, 22.5 to 27.5. It's the same procedure to calculate a class mark, which is midpoint ataupun kita kata midpoint, right? So 22.5, sorry, 17.5 plus 22.5 divide by 2. So it will become 20. This is the same example as before. So you will get the same value of class mark. So 22.5 plus 27.5 divided by 2, it become 25. This is 30, 35, 40, 45, and 50. So this is how we calculate class mark, right? Any questions so far? So now let's move to the next one. We have frequency. You already know the frequency value, right? So now look at example number 10. Before we end our class, look at example number 10. So example number 10, time taken in minute for 25 patients. So this value, the last row, total, should be equal to 25, right? So from the above table, determine lower class limit for the third class. So the lower class limit for the third class is, so if you look at the table, we have 2 until 2.99, 3 until 3.99. The value of upper class limit is not equal to the value of lower class limit of the next class. So this is a class limit. We don't have a class boundary. So since they ask you to find lower class limit for the third class, it should be equal to 4.0, right? So this is the value 4.0, right? Upper class limit of the second class is equal to 3.99. And the class mark of the fourth class, this is fourth class, right? So to calculate class mark, 5 plus 5.99 divided by 2. So it becomes 5.495. And lower class boundary of the second class. Lower class boundary of the second class. This is a second class. Lower class boundary is, since upper class limit for first class is not equal to lower class limit, so lower class boundary is 2.99 plus 3.00 divided by 2. It should be equal to 2.99 plus 3.0 bagi 2 is equal to 2.995. Right? Upper class boundary for the fourth class. Fourth class, where is the fourth class? This one, right? Upper class boundary, very simple. 5.99 plus 6.00 divided by 2. 5.99 plus 0.00 divided by 2 should be equal to 5.995. And the last question number 6, they ask class size. For this subject, we will maintain equal class size for each class, right? So class size, you will take from, let's say you take a 2 to 2.99. It should be equal to how much? 2.99 minus 2 plus 0.01. It should be equal to 1. Right? The relative frequency of the third class. Relative frequency of the third class. So this is a third class. So relative frequency 7. This is a frequency divided by 25. So 7 divided by 25 is equal to 0.28. So this is how we calculate relative frequency for each class. Right? Any questions so far? So I guess we're going to stop here. For the next class, right, we will continue histogram, frequency polygon, frequency curve, stem and leaf, and cumulative frequency table, and how to construct a cumulative frequency curve, or with what we call as a less than or give, right? And then we're going to finish chapter number 2, right? So we will meet again if there is no changes in perkeliling, right? We will meet again after 12th April, right? So I guess that's all for me for first part of the chapter. Right, we will continue on second part. So I think, do you have any questions so far? Any questions so far? If you don't have question, then I think that's all. Thank you very much. Assalamualaikum.